Hello and welcome to KG Tutorials. In this lesson, we take a look at the congruency of triangles. We speak of the triangles which have the same shape and the same size. Okay, what does congruency mean? Okay, so congruency simply means if we have two figures with same size and shape, then it means those two shapes or triangles are congruent to each other. And another thing, if maybe they have the same size and the same shape as the mirror image, then it also means the figure is congruent to the mirror image. Okay, so since congruency appear when we have the same size and shape, then it means if two or more triangles are congruent to each other, then we can confirm and conclude that they have the same size and the same shape. It's kind of like the converse of statement here. Now, if the two triangles are congruent to each other, then we will use this sign. It's kind of like an equal sign, but with three stripes this time. Okay, so that sign means congruent. Now we're going to talk about 4 cases of congruence. So the question is, when will you be able to see or to know that shapes are congruent to each other, especially triangles? Here we are talking about triangles. Okay, so when will you know that triangles are congruent to each other? So the first case here is when we have 3 corresponding sides which are equal to each other. So this is the first case: side, side, side. On our right hand side, we have 2 triangles which are congruent to each other because of their corresponding sides are equal. For example, AB corresponds with ED and they are also equal. So we have AB which is equal to ED, first side. The second side we have AC which is equal to DF. And the third side we have BC which is equals to EF. So we have 3 sides which are equal. So in that case we can conclude that these 2 triangles are congruent to each other with the reason side, side, side. So we have the second case. So the second case, we have 2 sides and 1 included angle. Okay, so it means 2 corresponding sides will be equal to each other, and also one corresponding angle will be equal. Right, we have AB which is equal to ED, that's the first side. And what is the included angle? We have angle A which is equal to angle D, so that is an angle. Then we have line AC which is equal to line DF. So these 2 triangles are also congruent to each other. What is the reason this time? The reason or the case is the side, angle, side. Now let's look at the third one. Now the third one says 2 angles and the corresponding sides. So this time we have 2 angles and 1 corresponding side. Right? So in triangle ABC and triangle FED, right, angle A is equal to angle D. That's the first angle. And then angle B is equal to angle E. That's the second angle. And now the corresponding sides, we have line BC which is equal to line FE. So we have 2 angles and 1 corresponding side. So In this case, we can conclude that these two triangles are are congruent to each other. So this is the case this time. So we have angle, side. Then now the last one, the right angle, and hypotenuse and a side. So this one most of the times always it will occur on the right angle triangle. It's not gonna come in any other kind of triangle, but it's going to exist in a right angle triangle. Okay, so in this case, look at triangle ABC, and then we will see that we have the right angle A, and on the other triangle as well we have right angle D. So obviously right angle is equals to 90 degrees, so those both triangles have 90 degrees. Okay, right. Then the second one, the side which is opposite to the 90 degree angle, it's an hypotenuse. Okay, so that side right there, that side we have EF, which is the hypotenuse which is opposite to the right angle. They are also equal as well. So BC it's equals to EF, and the last thing we have BA is the side to this one, which is equals to DF. So here we have the right angle, the hypotenuse, and a side. So those are the 4 cases of congruency. So now, how do we prove congruency? So that's the kind of a question we want to ask ourselves. How do we prove congruency? But we already talked about the cases that should hold when you conclude, before you can conclude that two triangles are congruent to each other. So now let's just take an example. Suppose I have a parallelogram REAEV. Okay, so and maybe they say to me I should prove the congruency between two triangles. So in there I have triangle RAV and triangle RVE. Okay, I hope you can see that in that parallelogram we have two triangles, so you must be able to separate the two. So now you start by writing, before you prove congruency, you start by writing down that in triangle RAV and triangle VER. So why are you writing this statement? You are writing this statement to show or to note that you are working in these two triangles, because sometimes you might have more than two triangles in the same diagram. So you really need to note down that which triangles you are working with here. So in this case we are clear because we only have, fortunate enough, two triangles. So now we wanna note down the things or the sides or the angles that are equal to the other triangle. So now the first thing that we will see here is that line RE, which is 8 centimeter, it's equals to line AV of the triangle RAV. Okay, so this is given already. It is given, so we don't have any other reason for that, but it's given now. So we have proved one aspect here, so it means we have a side. So now if we can look at it closely again, we have a line EV which is equals to line RA, okay, which is equals to 5 centimeter. So that's another side. Okay, so now we have to prove the last thing. So looking at this, we have side RV which is being shared by those two triangles. So it means since it is shared by those two triangles, it means RV is equals to RV for both triangles. Why? This common side, because it's a common side. It is being shared by two triangles. Okay, so it means in this case we have proved congruency using the case number 1, side, because those are the only thing we were able to prove. So triangle RAV, after you write down those 3 statements, this is how you want to conclude that you have already, indeed you have reached the congruency part. So say therefore triangle RAV is congruent to triangle VER. So you also need to write down the case, which is the side. So this is how you prove congruence. For in case you come across a question that says prove a congruency of triangle this and that, so this is how you want to prove your congruency. You want to check out the corresponding sides which are equal, or sometimes angles. Let's just look at maybe another example. For example, so in this case, before we look at that example, by congruency help us with a lot of things. So by congruency, since we have proved that triangle RAV is congruent to triangle RVE, then it means these two shapes are equal, right? So since they are equal, then it means the also corresponding angles are also equal. So for example, angle A will be equal to angle E, since they are both been subtended by a common side, RV. So this is kind of a reason you can work on corresponding angles in a congruent triangle are equal. Okay, so let's just look at another example, just for the sake of more knowledge, right? So here we have 2 triangles. We have triangle PQR and triangle SQR. Okay, so the first thing that we would notice is that angle P is equals to angle S. They are both 90 degrees. It is given. Okay, and then we would notice that line OQR is common in both triangles, because those 2 triangles are both being subtended by a line QR. So in that way, it's a common side. And the third aspect here, now we have the PQ, which is equals to SR. It is given because it is being marked by a mark sign there. So it means it is given. Okay, so in this case, because this is a right angle triangle, so this will be the case that you will use. You say triangle PQR is congruent to triangle SQR. Then you want to write down the reason here. So in the cases we use the R, so it's still fine. The R 90 degrees, no problem. So that is the case you want to write down there. So it does not matter whether you write the R or the 90 degrees there. So as long as you have represented your answer very correctly and appropriately. So the congruency help us. It's very important because it helps us with a lot of things. So for example, we are able to prove theorems using the congruency. Here I have an example of a theorem that is being taught in grade 10. So if 2 opposite sides of a quadrilateral are equal and parallel, then the quadrilateral is a parallelogram. So we used congruency here to prove that the quadrilateral ABCD is a parallelogram. Okay, so meaning the shape was a parallel, was a quadrilateral which had only 2 parallel sides, BC, which is parallel to AD, sorry, and then we had to join AC in order to create 2 triangles. So when we have 2 triangles, then we can prove congruency. So looking at this, we have angle A1. Where is A1? A1 is right there. It's equals to C2. If you can look at this, that is an alternate angles because they make a Z and we have parallel sides. So BC is parallel to AD. Okay, so another thing, we have AC, which is a common side. It's been shared by 2 triangles, and then we have the AD, which is equals to BC. So we have the AD, which is equals to BC. So it's given, it's marked there already by that mark there. So we have proven three things. So we can conclude that therefore triangle ABC is congruent to triangle CDA. Okay. So we had a side and one angle and another side. So by this we are able to conclude that line AB is equals to line DC, because they are congruent to each other, those two triangles. So since they are congruent, it means they are equal in shape and in size as well. So, and as well we can also prove that AD is equals to BC. So congruence will help us with a lot of things, you know, especially when we are going to talk about the theorems or be learning the theorems. So you really need to know how to prove congruency, because congruency will play a big role, especially in the theorems that we'll be learning in grade 11. So you want to make sure that before we talk about the theorems in grade 11, you really know the cases of congruency and you really know how to prove congruency. Because if you know how to prove congruency, then it means a lot of things will be easier, especially when we are doing the theorems, because most of theorems require congruency. And also it will also help you in the riders when answering the riders, because sometimes you want to prove that one side of a triangle is equals to the other side of a triangle, but you don't have any kind of a relationship that you can relate those two sides to. So but if you can prove that those two triangles are congruent to each other, then you can conclude that the other side is equals to the other side. You know, the other side is equals to the other corresponding side of the other angle triangle. Sorry. So I can speak a lot of things here, but thank you for watching and have a nice and a blessed day. Let us meet in the next lesson. Okay.